guys, Dr. Burns here. Let's take a look at section 2.2, which we're still talking about numerical distributions and the features we're going to use to describe a numerical distribution. Make sure your cell phone is put away, turned off, out of sight, so you can really focus and concentrate for the next 7 or 8 minutes. So remember in the last section we mentioned that there are 3 important features that we always want to talk about when we describe a numerical distribution. So the first was the shape, whether the data was symmetric or skewed and had different modalities. The center, what was a typical value that represents the data set. And then finally the spread or the variation, how spread out horizontally is the data. Let's start with shape. So for shape, there's really 2 options we're going to go with here. We're going to say, is the data either symmetric or roughly symmetric? It's not ever going to be perfectly symmetric, but roughly symmetric. Or is it skewed, either left or right? We may also talk about how many mounds there are, which is kind of a funny word, but that literally what I mean, like in this picture down here, are the mounds. If it's got 1, we say it's unimodal. That's also the modality, we might say. If there's a couple of different, like sort of peaks in the graph, then we would say bimodal, and we can sometimes have something that's got more than 2. And also, are there any unusually large or small data values present? We may also call those outliers. So symmetric would look just like we would expect, almost like a bell-shaped curve. And again, I use the term symmetric loosely. We could say roughly symmetric or approximately symmetric. It's never going to be perfect. When we talk about skewed, we would either say skewed right or skewed left. And in this picture that I have here, this would be a graph that is right skewed or skewed right. When we talk about the skewness, we talk about where the tail of the graph is as it tapers off. If it tapers off on the right side, then we would say the graph is right skewed. If I had a graph that was the opposite, so let's say the tail was like that and the bulk of the data was on the right end, so if the tail was this way, we would describe that as left skewed. Generally, we're going to work with data that is unimodal, but occasionally you'll come up with something that's bimodal, and that usually means you have more than one group in your data set. When you talk about data that is multimodal, those peaks in the graph can be different heights, so they don't have to be exactly the same. As you see in that second picture there, you can see that there are 2 peaks in the graph, but this one is noticeably smaller than this one. Bimodal or multimodal data may indicate the existence of different groups. Sorry, this is a little bit messy. I didn't leave you a lot of room, so just do the best you can. Different groups. So, for example, maybe we're comparing heights for men versus women, and that might be something that we have in the data set that indicates we're looking at different groups. If that happens, it's often preferable to separate into 2 different graphs. We generally don't want to compare different groups on the same graph because that gets a little bit confusing. For example, men's and women's heights. Outliers. So outliers are data values that do not fit the pattern for the rest of the data. We may say that these are unusually large or small values in the data set. They aren't precise. It's not a precise definition. This is a little bit opinionated, what we consider an outlier. Later on in the course, we'll have some cutoffs for what we would say is an unusual value that we would consider outliers. But for now, it's a little bit subjective. For now, if you have a data value that looks like it doesn't fit the patterns, you can call it an outlier. And when you see that, make sure to report those values in your description. And also realize that sometimes outliers could be errors, and that'll happen. Like somebody might record Whereas if somebody weighs 150 pounds, they might put an extra 0 and make it 1,500 pounds. Obviously, somebody doesn't weigh 1,500 pounds. Genuine outliers, though, are usually very interesting data values to consider. So here's just a basic graph. This is a histogram. You can see the shape of this graph, by the way, we would say is right skewed, because we can see it kind of tails off. The bulk of the data is on the left side, so it tails off to the right, which means it's right skewed. And the values over here could be considered outliers. So one thing we want to talk about is the shape, which, like we said, we want to describe whether it's symmetric or skewed. If it's bimodal, you want to mention that. If you have any outliers, you want to mention that. The next thing you want to talk about is the center. So what we consider a typical value or something that is representative of this data set. And for now, what is a typical value? That's a little bit subjective. You may even give a range of numbers that could represent a typical value or a center visually, a center of the data set. Later on, we'll be a little bit more precise about how we define this. And then finally, the last thing you want to describe when you're talking about numerical data is the variability. Look at the horizontal spread. So literally left to right. How spread out is the data? If the data points are very far apart, we'd say it's got high variability. If they're really close and clustered together, we'd say it's got low variability. And as I mentioned, we're going to be a little subjective now. We're kind of eyeballing this, but we'll get more precise about this later on. So tomorrow in class, we'll look at some graphs and we'll practice describing them in terms of these three characteristics. So make sure you bring your notes, and I'll see you in class.